Hello College math students, in this example we're going to find the length of a sloping edge on the Great Pyramid of Giza, which of course is located in Egypt. Okay, so we want to find this length here. So in this three-dimensional representation of this triangle, we can sort of rip that triangle there out of the diagram and draw it in 2 dimensions. So by that I mean something that looks like this. Okay, with that right angle and this sloping edge L. So see how I've taken this triangle here and taken it from 3 dimensions to 2 dimensions. We're told that the height, the vertical height, is 146.6. So that's this length here. So this is 146.6 meters, this height here. So we've got one side of this triangle. If we had this bottom side here, then we could use those 2 sides with Pythagoras' theorem to find the sloping length L. So what we want really is this side here, which is that there. We want to find that. Okay, so this is how we're going to do it. Okay, now I'm going to utilise this triangular base here, from here to here to here. And of course I only really need this bit here, but if I can find the length of all of that from there all the way to there and just halve it, then I can just get that red bit there, which is half of that total length. So that triangle would look something like this, say. And we're told that the square base is 230.3 on each of these sides. So 230.3, 230.3, it forms this right angle here, which is difficult to see in 3 dimensions, but there's a right angle down there. Okay, so this length here, I'll just call this, we've already got L. I'll call this X. Okay, X, using Pythagoras' theorem, is the square root of the 2 sides squared and added, because we're finding the hypotenuse of this right angle triangle. And that gives us, actually at this stage I might divide this by 2, because we need to halve it anyway. So this whole thing divided by 2, and you can put this all into your calculator in one go. And this gives us 162.8 meters. So that's that length there, 162.8. So now we have this length here. It's 162.8 meters. Okay, so we're going to use Pythagoras' theorem again to get L. I'll do it on this picture over here because I'm running out of room. Okay, so L equals the square root of the other 2 sides squared and added, because once again we're still finding the hypotenuse. Actually, that's not much good. Does it look a bit better down here? Yep. Okay, so if we put that into the calculator, what do we get? 219 or so. 219.1 metres. There's our final answer for L. Now, you may have taken a slightly different approach to this, but you can still end up with the same answer, and if you've done that, that's absolutely fine. Now, you'll be confronted with other types of three-dimensional problems. It can be a bit challenging to visualise, but just do your best, and remember that I'm in the class there with you, so if you get stuck, get me over to give you a hand.